All right, we are in Unit 1, Lesson 10. We are looking at Chapter 6, Section 1 in the textbook. If you want to go look in the online textbook at this lesson a little bit more in depth. This lesson is on operations on functions, and we're going to be looking at radical functions. Our content standards in this lesson that we're going to talk about are we're going to be comparing properties of two functions that are each represented in a different way. And they could be algebraically or graphically, numerically in tables, or by verbal descriptions. And our second standard is that we're going to combine standard function types using arithmetic operations. And the mathematical practice we're going to focus on is reasoning abstractly and quantitatively. So in the past, we've performed operations on polynomials, and what we're going to do in this lesson is find the sum or difference or product or the quotient of a function, of multiple functions, and we're going to do composition of functions, and composition is probably a new concept for you. Boom, there we go. Composition is new vocabulary. So here's some basic operations. This is the key concept box. Basically, if you want to add two functions, it's going to be written as f plus g of x, which equals f of x plus g of x. And the basic operations at addition, subtraction, multiplication, division, they work just like you would expect them to work. So f times g of x is f of x times g of x, f minus g of x is f of x minus g of x, and so on. So let's jump into some examples. So our first example, what we're going to be focusing on is adding and subtracting functions. And our first says, part A says we are given the function 3x squared plus 7x, that's f of x, and g of x is 2x squared minus x minus 1, and we need to find f plus g of x, which basically means we need to add the two equations together. So we're going to combine our like terms and then simplify. So we have 3x squared and 2x squared. That makes 5x squared. We have 7x minus x. That gives us 6x, and then we have minus 1. So let's look for that answer in this next slide. And there we go, 5x squared plus 6x minus 1. Skip through this slide, same thing. All right, this time we're going to take our same two functions, but we're going to find f minus g of x. So this time we're subtracting f minus g, so 3x squared minus 2x squared, that's 1x squared. 7x minus negative x, minus a negative is plus, so 7x plus x is 8x. And then we have nothing minus 1 would just be, oh no, it's not nothing minus 1, it's nothing minus negative 1. So again, two minus signs makes a plus. Basically, we're distributing this negative sign to all the terms in the second set of parentheses. When you do that, we're going to end up with x squared plus 8x plus 1. All right, here's a problem for you to check yourself on. You have f of x is 2x squared plus 5x plus 2. G of x is 3x squared plus 3x minus 4. And you have to find f plus g of x. All right, our answer for this one is A. Our next one for you to check is, we're looking at the same two equations. This time we are going to subtract f minus g. Pause the video, and when you have your answer, come on back and advance to the next slide. And our answer this time is D. All right, example 2, we're going to be multiplying and dividing different functions. So in part A, we have f of x is 3x squared minus 2x plus 1. G of x is x minus 4. And we have to find f times g of x. So we're multiplying our two functions this time. when we do that, it's kind of like foiling, but really it's just an elaborate distribution. So we're doing, let me pull up my writing tool in here. We're going to do 3x squared times x, and we're going to do 3x squared times negative 4. And then let me change colors. We're going to do negative 2x times x, negative 2x times negative 4. And then we're going to do 1 times x and 1 times negative 4. And when you write all that out, it's going to look like this. When if you simplify that and you combine all your like terms, you should end up with 3x to the third minus 14x squared plus 9x minus 4. All right, in part B, we are going to take the same two functions, but this time we're going to do f divided by g. It's important to note in this, if we're dividing by g, the x can't be 4, because if x was 4, we would be dividing by 0, and you know you can't divide by 0. So how do we divide one function by another? What we're going to need to do, oh, well, never mind. They're content just leaving it that way. There will come a time this year when we cover how to actually divide this function by this function, but it seems like for right now that they're going to be okay with you just leaving it the way it is. Okay, here's one for you guys to check your progress on. You have two functions. You need to multiply them together. Pause the video as long as you need. When you have your answer, come on back and advance to the next slide. And the answer to this one is C. The next one, we're going to do the same two functions. We're going to divide the two functions. Think about what would be on the bottom. The answer should be pretty obvious too. Think about what x will not be allowed to be so that we don't divide by 0. When you're ready to have your answer, go on to the next slide. All right, this time our answer is B. Okay, the new concept is composition of functions. And if you want to talk about composition in just words, composition, the way it's explained is, suppose f and g are functions such that the range of g is a subset of the domain of x. Then the composition function f composition g can be described by f composition g of x is f of g of x. So basically what this terminology means is that you take the g of x function, we're going to take whatever the g of x function is, and we're going to replace all of the g of x function with the letter x anytime you see it in the f of x function. So that should be a little bit more obvious once we look at an actual example. Wow, this is confusing. Okay, example 3, we're going to compose functions in this problem. It says f of x, it looks like it's a set of coordinate points. It's the point 2, 6, it's 9, 4, it's 7, 7, and it's 0, -1. And g of x is 7, 0, it's another set of points, 7, 0, -1, 7, 4, 9, and 8, 2. But we need to find f composition g of x. So the concept here is we're going to take the g of x values and we're going to throw them in the f of x function. So let's see how that's done. Okay, so it says to find f composition g. First we need to evaluate g of x. Then we're going to use the range value. That's the y value of g, and that goes in the domain, the x value of f. So for example, if we wanted to find f composition g of 7, we first would do g of 7. g of 7 is 0. The y value for 7 is 0. And then we find f of 0. F of 0, here's 0. F of 0 is negative 1. So f composition g of 7 is 0. I mean, it's negative 1, sorry. F composition g of negative 1, go to g of negative 1, that's 7. Then go to the f of x, find 7, the output is 7. So f composition g of negative 1 is 7. F composition g of 4, find g of 4, oh that's 9. And then for f of x, go to where 9, output is 4. So f composition g of 4 is 4. And so on. Hopefully you picked up the pattern from that. Okay, next time, this time we're going to do G composition F. We're going to do reverse order. So this is, it's not obvious to you from here, but you're going to need to go back 2 slides in order to see this. But let's go backwards. I'm going to go back the 2 slides and show you, or I can just go back 1 slide. If I want to do G composition F, so first I would find F of 2, that's 6. And then I would do G of 6, that doesn't exist. There's no 6 value here. So that won't give us anything. Then if I do F of 9 is 4. Then I go to where G is 4, and that's 9. So 9 is in G composition F. Let me write that out. G composition F is going to be 9. What other points? Let's see. F of 7 is 7. Take that 7. G of 7 is 0, so 0 is also in here. F of 0 is negative 1, and negative 1, the G of negative 1 is 7, so 7 is also in G composition F. Let's go back to the slide. Let's go back forward and see what they find. Remember this? This was undefined. We couldn't find. There was no there was no G of 6, so we couldn't do that. And then our other points that we got on the previous slide were just 9, 0, and 7. So those are the numbers that would be in G composition F. Okay, part B of example 3, we're going to find F composition G and G composition F. And we have the functions 3x squared minus x plus 4 for F, and G is 2x minus 1. And we're going to state the domain and the range for each of the combined functions. So the first thing we're going to look at is F composition G means that we're doing F on the G of x function. So the G of x function is 2x minus 1. So we're doing f of 2x minus 1. So that means anytime you see x in the f function, you're going to replace the x with, in parentheses, the quantity 2x minus 1. So when we do that, it's going to look like this. Notice how before this was just x, before this was just x, and it's being replaced with the 2x minus 1. Then you're going to need to multiply all this out, combine your like terms, and then simplify. And when you do all that, when you simplify, you get 12x squared minus 14x plus 8. For G composition F, you're starting with f, and you're plugging the f function in anytime you see the x on the G function. So the G function, remember, was 2x minus 1. Let me write that real quick. It was just 2x minus 1. So you're replacing this x with the f function. That was f. When you multiply that out, you're going to get 6x squared minus 2x plus 7 after you multiply it by 2 and you subtract the 1.